Okay, then today let's discuss about the practical exercises which we discussed last time, which we plan to conduct. So, because of your busy time schedule, I promise you to do the recording and send you the file. So, in this one, we will have like four practical sessions. First one will be a basic possibility modeling for using the environmental buffers. We will do the proximity modeling analysis, and then we will have another exercise, multi-criteria evaluation for site suitability analysis, and then we will have another exercise dedicated for spatial join and socioeconomic data synthesis, and then we will have another exercise regarding remote sensing, especially like satellite images, how we can like do a simple digital image classification. For the first exercise, we will go with this simple proximity modeling and environmental buffers. So in this one, we need to have these three basic data sets. Actually, in here, what we are going to do is we do have a road and riparian act, protecting act in Sri Lanka. So which basically means if we have road network or private what we call inland water or something, we need to give allocate some specific distance for this specific road as a reserve. So now we are going to calculate the amount of reserve for the road networks and the inland water in administrative district in Kandy. So for this one, we need to have like three specific data set. First one is road network of Sri Lanka, and then the inland water network. It will be like basically the geometry type will be line, and then for the road network also it will be line, and then the administrative district it will be in polygon. For by clicking these links, you can download the data directly, but for your ease, I have uploaded these all the data files in here in my Google Drive, so you can right click and download. For the first exercise, I will download the zip file. It will take me a while the data file is downloading. I will load the arc map in my laptop. So first we need to have this three data sets. So basically what we are planning to do is we will do the buffering as we discussed, because we need to buffer. Road network is line feature, so we need to buffer according to the given criteria. So specific distance is like if it is a major highway, we need to give 300 meters from both sides, and then if it is inland water body or something, we have like two different criteria. If it is a minor stream, then it should be 50 meters, and if it is like a big river like Mahavali or something, then we have to allocate 150 meters from both sides of the river. So then we need to do the buffer. This one we will use buffer by using a specific field. For the first one, we will use the single feature buffering. So I will discuss when we go to the practical, and then we need to do the geometric analyze how many hectares we are going to allocate for this road and riparian act in Kandy district. We are not going to discuss about the entire Sri Lanka. We are going to discuss only in the Kandy district. Okay, first you need to load the ArcMap, and then this is the interface of ArcMap. So you can create an untitled map, and then for here is asking where you going to save the file. I will click browse more. I can go for browse more, and then now I will go with the basic recent untitled map, and then I will click open. This is my previous work. I will go and like open file, new. Under new, it's asking me to give the default database for this map. I can create a different geodatabase. So for this one, I will save this file. First, I will add a folder connection. So I will save all of the exercise outputs and the files in my D drive. I will create a new folder for CMB 40 So in this folder I will create another folder named ex01. So I will select this ex01 folder in my D drive. So my geodatabase will be located over there. So I can create a new file database from here. I will type it as ex01.gdb. So I can select this database and click add. Now my geodatabase is located in here. Now I will click on blank map and click on OK. So now I do have the blank map. Right now I am in the, from here if you see, we do have like two different views. This first view is what we call layout and the second view is map. So whenever you are creating a layout, you have to go for the second one. If you are creating one working with a map, you have to go with first one. So I will click here on the data view. Now I need to import the data over here. Before that, I will save this project. I will click file and then save as. I will go and select my folder which I have been selected previously in my D drive, CMBA40 prac ex1. Over here I will save this one as ex1 dot 01.mxd. So now my both if I go, I will open a file manager window and I will go to this PC local disk D, and over there I will see CMBA40 ex01. I see these two files. First one is my geodatabase file, is not a typical folder, and then the second one will be my ArcMap file. So this is how you are organizing your work, how you can organize your work very well. So let me see and check whether the download is finished. Yeah, my download is finished. So I will extract this file from here. I will copy this one and move that file into my D drive under ex01. So I will copy that file here and then I will right click and extract all the necessary files into this specific directory. So I can go under view more, extract to ex01. So now it will extract all the necessary files that I need to do this exercise. So after that I will delete the extracted file. So here you see the district SHP file and then the road network file and then the stream network file. So these are the three different files that we need to run this simple exercise. Now we need to load the data into the map window. So how we can load the data? We can click here. If you go over there, you will see at data icon over there. So I can press here and click on add data, and then I can put the data from here as well. But this is a bit complicated thing, so I will go with the easiest thing that you can do. Just click on window and click on catalog. So when you click on catalog from this side, you can ping this catalog into your view. So from here I will add a folder connection. So if you see this button, you can connect to a folder. So I will do the folder connection. Actually I don't want to do the folder connection because previously I did the folder connection when I am creating the sample. So I can just right click over there and hit refresh. Now you see my exercise 01 folder is over there with all the necessary files that I wanted to do this exercise. So now I will load this file. First one will be the district shape file because I need to have the district. So I will drag and drop this one into my map window. So now I do have the map, and then I need the road network shapefile. So I will drag and drop it over there. So now I do have the road network file, and then I will drag and drop my stream network file into my project. But main thing in here we have to consider is we need to convert, because right now here I mentioned we need to reproject the data from WGS 84 into Sri Lankan Kandawala grid in meters. So when we are doing the calculation, it will be easy for us. For this one, we have to use the reproject layer tool. So I think you know about this tool, what we are doing. If I inspect this one, I right click and go to the properties of this layer, and if I check the properties, take me some time, go to the sources. From the sources I can see now I am using the coordinate system GCS, that means geographic coordinate system WGS 1984. We need to convert this WGS 84, that means the geographic coordinate system, into the Kandawala projected coordinate system to do with our further calculation. So the first step is converting all the layers into the Kandawala grid. So it will be easy for us to move ahead. So how we can do that one is just click on Windows, and then you can click on uh, search. So when you click on search, you can see the search bar is also appeared. I will tag the search bar in here. Now in here you can search all the tools that you wanted to, that you need or you will use in this ArcGIS. If you click on tools, you will see all the installed toolboxes in your Arc map. So in here I will search. So first tool that we need is we need to do the reprojection. So what we how we can do the reprojection? I can type reproject in here. So if I type reproject and search, you can see here I do have a tool called project under data management tools. So if I click here, it will take some time. So now the projection tool came. So now I have to select the input data set. So my input data set will be, so I will take a screenshot and attach this one over there in the Word file, so it will be easy for you guys to follow up when you are doing your work. So I will attach this one in my Word file, so it will be easy for you guys to do the practical. So okay, first you have to do the projection. So the project, in the projection you need to input the data set or the feature class. So we need to do the projection for these all the three layers first. So I will select the district first. I will select district first, and then it's asking me where this output dataset feature class is going to be saved. So it will be saved in the my database where DCMBA40 EX01 EX01 GDB road network projected. So I can say this one road network projected for Kandawala. I will type KD. So now we have to select the output coordinate system. From here you can click on this small icon, and then it will load this window where you can see multiple projection systems. So here we have to search for Kandawala. I will type Kandawala from in here and then hit enter. So it will take a while to filter the projected coordinate system. So from there, under the projected coordinate system national grid in Asia, I can see Kandawala Sri Lanka grid. So if I click here, you can see I have some basic information in here regarding the scale vectors and some things. I will select Kandawala Sri Lanka grid under the projected coordinate system, not under the geographic coordinate system. Even in geographic coordinate system, you can see this coordinate system, but since we are dealing with planar maps, we have to go with the projected coordinate system. So I will select Kandawala Sri Lanka grid from here and click OK. Then I just need to click OK. So after I click OK, it will take a while to process this one for the conversion. After a while, you should see your layer should be appeared on this layers panel. So now I do have this road network.kd file. If I right click this one and go to the properties and do the under the sources, I can see the projected coordinate system is Kandawala and transverse, and most important thing is area linear unit. So now we do have the linear unit in meters, but in previously we had the linear unit in degrees. If you go there into the previous districts file and open it up, the properties, and then if you go down you will see the angular unit in degrees, because the geographic coordinate system we considered the entire globe. For the projected coordinate system we consider it as a flat plane uh, map. That's why we do have degrees in geographic coordinate systems and meters in projected coordinate systems. So now I don't need this district file because I did the conversion to the Kandawala coordinate system. So I will remove this file, and then now I need to do the conversion for the road network. So I will do the same thing, go to the project and then select the road network, and then rename this one as road network dash Kandawala. To represent Kandawala I will type KD. From here then you have to select the same coordinate system again. Since I do have a layer named Kandawala, the already projected road network thing, I can click on layers and click on Kandawala Sri Lanka grid and hit OK. Actually, I did a mistake. So here I rename this one as road network. This is not actually the road network. This one should be what? I will rename this one. Oh, I can click on data, export data. I can export this one as the same file where my folder connection. From the folder connection I will select practical ES1. Let me go to the catalog. From the catalog I can refresh this exgdb file. I can refresh this one, and then I can rename this file into this streets.kd. So I made a mistake over there, that's why I'm doing this one. I will remove this one and drag and drop this district layer. So now if I open this one, I can see it's in Kandawala coordinate system, actually the projected coordinate system, and in meters. So now I will do the conversion for the rest of the two layers, road networks and the stream network. I will go to the search, project, and then click the stream network. First I will do it for the stream network. I will say stream network dash Kandawala underscore Kandawala, and then from here I will click layers, then I will select Kandawala grid, click OK, and then hit OK. So it will take a while. From here you can see now the tool is running. So Stream network is also converted into the Kandawala projected coordinate system. If I go to the project, the properties, I can see is converted into the Kandawala grid coordinate system. So now I will remove the stream network from here. Lastly, I will do the projection to the road network layer. So from here, I will select the road network, and then I will say road network KD. From here, I will select the Kandawala coordinate system again and click OK, and then hit OK. So it will take a while to convert the road network. So from here, if you right click on layers and go to the properties, by default you can set the coordinate system for this specific exercise. From here you can select the specific coordinate system. From the layers, I will select Kandawala. So if I click apply and OK, what will happen is, for all the further calculation which I am going to do, it will perform no matter what, it will perform in Kandawala coordinate system in this specific layer. So I will click yes. The projection is taking a while because for the road network actually we do have a big area with a huge amount of data, so it will take some time for the conversion. Okay, now the road network is also converted. So if I click on the road network properties, I can see it's also converted into the Kandawala. Previously, road network is also in WGS 1984. So why we do have WGS 1984 is like world recognized system that we are using, but in Sri Lanka we are using Kandawala. Okay, now we do have this one. We are not going to do that road riparian act and like how much reserve area is covered in the region using for the entire region. Actually, we are going to do this one only for the Kandy district. Now what we need to do is we need to clip the data into a specific district. That means the Kandy district. So how we can do is we just need to right click on the district and district shape file and open the attribute table. From here, when you open the attribute table, I will drag this one and dock this one in here. So from here, if you see closely, we do have the district files under the admin2 name Kandy. So from here, I will select the Kandy layer file from here either. Otherwise, you can click on the select by attributes icon, and then you can select ADM2 name from here, and then I can select equal, and then I can type get unique values. If I click unique values here, you can see all the values. From here, I will select Kandy and then click apply. So you can see now Kandy province is Kandy district is highlighted on my shape file. So now I need to clip the stream network and the road network which is actually covering the which is containing in the Kandy district. So how I can do is first I will extract the Kandy district only. So to extract the Kandy district only, first you need to select Kandy from here, and then there's two ways. I will select for the clip tool in here. So from here you can see under the analyze tool we do have clip. I will click on the tool from here, and then I will select the input feature. My input feature will be district. From the district KD, clip the feature which is I see with the which I selected the Kandy district. So from here I will say like this, and then I will hit Kandy as my output feature class, GDB district Kandy. So double check this should be over there, because after you finalize the exercise you need to submit this geodatabase file along with your project file for the evaluation. Okay, now I can click OK. If I click OK, it will take a while. After a while, you can see I will untick these two layer files from here to show you guys what happened actually. So if I remove this district KD tick, you can see the Kandy district is cut out from the actual district shape file. So now we don't need this districts KD file actually anymore. So I will remove this one from here. Now I need to clip the stream network and the road network inside the Kandy district. So how I can do this one is the same thing. I will use the clip tool. So I will here also I will take a screenshot. You have to use the clip tool in the analysis toolbox to do the clipping part when you are selecting the data. So here for this part you need to have the clipping part. The next part will be the clipping for the Kandy district. You have to do the clipping for the Kandy district, and then I will do the clipping for the input features. Right now I need to do the clipping for the road network, and then clip feature will be Kandy district. So inside the Kandy district I need the road network. So here I can type road networks in Kandy, road networks dash Kandy, and then I can click OK. So now if I untick this road network KD, you can see the Kandy road network is over there, which is like converted into Kandawala, and then we clipped it into the Kandy district. So now I will remove this road network KD file. Now the last file is stream. I need to clip the stream network inside the Kandy district. So here input feature will be the stream network, and then my clipping feature will be district Kandy, and then in here I can rename my output layer as stream network Kandy, and I can click OK. Now I do have the stream network also. So if I untick this one and right click on the stream network and click on zoom to layer, I can see the stream network which are going inside the Kandy district. Okay, now we need to do the buffering part. So how we can do the buffering part? So the buffering part is simple. For the road network is simple. For the road network, I will do the buffering part first. So if I click on the road network, this is the road network. And then for the buffering of the road network, because we need to allocate 300 meters from both sides of the road. So for this one, I will click on search for the buffer tool and click enter. Now I do have this buffer tool in the analysis tool. Then from there, I can click on input feature for the road network. Now I will select road network in the Kandy, and this one should be road network Kandy buffered for uh, 300 meters. So the linear unit, here I have to select the linear unit, and the area unit should be 300 meters, because here I specify we need to give 300 meters. And then site type option, here we can like select full, and then the method is planner, and then most important thing is dissolve type. Here we have to select all, so all the features will be dissolved, and we will end up with one single feature. So now I will take a screenshot of this one as well and attach it over there for your reference for the buffering of the road network first. And I can click OK. After I click OK, it will take some time for the buffering to run, and then we will see a 300 meter buffer zone in the all road networks. So it will take some time for the buffering. So meanwhile it is going on, I will zoom this map into a specific region. So after the buffering, we can see how buffering has done. So let's wait till this one finish. Actually, what we should see, this is a road network in here. So we need to see 300 meters to the left and 300 meters to the right in this network. Okay, now you can see the buffered layer is there. So if I go into the this measure tool, click over there, and then if I click on measure a feature, and then if I click over there, distance, we need to create a line. I will draw the line from here to here, so you can see it's roughly 300 meters. So 300 meters to the left side and the 300 meters to the right side. So you can see it's actually created the buffer for the road network. So now the next thing is, I will zoom into this entire region now. Okay, this is the buffered layer network. So from here I will remove the road network, because now I did the buffering for the road network. So this is the buffered zone for all the roads, and now I need to do the buffering for the stream network. But for the stream network we have a small issue, because in here we need to have inland water, and then we do have like two different criteria. So if it is a other river, it should be 50 meter, and if it is a major river like Mahavali, it should be 15 meters. So how we can specify these two kind of varying buffering zones? So it's also simple, but before we go with the buffering, actually we need to do some modification in the attribute table. So for this one, I will open up the attribute table. After I opening up the attribute table, from here you can see I do have some fields. So in here I will add a field uh, to do the variable buffering. So for this one, I will create a field. So how we can create a field? So we can click on table, this option in here. Okay, now I do have this one. I will click add field. So this one I will type uh, buffer underscore distance. So here I will type, it is not short integer, it should be either double or a long integer. So I can say double and then click OK. Now you can see a new field has been added to our attribute table of the stream network. Now we need to do a simple calculation. Actually, we need to do a simple calculation for this one. So we need to do the buffer distance, right click on this one, and then we have to do the field calculator. So we have to use the field calculator from here, and then we have to see click yes, so it will modify. So now we have to do some simple trick in here. So if it is Mahavali river, we need to type it as like 150. So I will say we don't need to do that much logic. I will do the simple thing, select by the attribute, and then from here you can see the river name, in name Mahavali Ganga. So I will type num, then equal, then get all the unique values. I will say Mahavali Ganga, then click apply. So now I can see, if I filter all the rows here, I can see all the attribute names which were ending with Mahavali Ganga. From there I can right click after selecting, then click on the field calculator, and then I will click yes. Then for the buffer distance in here I can type 150, because for Mahavali river I said we need to have 150 meters for the Mahavali river for the buffering, and then 50 meters for the minor streams. So here we do have 150. So I will say 150 for the Mahavali river and then click OK. So now you can see the buffer district for this one is applied. For the Mahavali river is applied as 150. And then I can select the switch selection tool from here. I can select the inverse. Then for all the rest of the values, I can click here, right click, and then from the field calculator, I can type 50, because for Mahavali it should be 150. For all the other rivers it should be 50. Now if I view all the attributes, I can see for Mahavali Ganga there's one field called buffer district, buffer dist. The value will be 150. For the rest of the rivers it will be 50. After you editing this one, you can go into the editor toolbar, or you can click on Ctrl S to save your project, and then you can go to the buffer in the analysis tool again, and from here you have to select the stream networks, and then this one will be stream network Kandy, and then is buffered. So these are the stream network buffered. So the only modification that you have to do in here is, instead of linear unit, you have to select the field from here. Then for the field I will select the buffer distance field. Then rest of the things are same, side to side full, in type round, method planner, and then the dissolve option I will select dissolve all. So take a screenshot and attach this part to the document as well. So this is how you can do the buffer analysis for this stream network part. Then I will click OK. So actually here I made a mistake. I will run the buffer tool again because I selected some features in here. So I will click on buffer. Then the input feature will be stream network Kandy. Then this one will be same buffered. To be field. Saying let me delete this previously created file from the catalog. I will go over there and then delete this Kandy buffered stream network Kandy buffered file from here. And then I will go to the search window again, click on buffer, and then stream networks Kandy field, and then select the buffer disk field, and then this all, click all and hit OK. So now you can see the buffer for this one is also created. So I will zoom into one specific network. So here you can see one river is going on. So if I click from this river to the bank, it should be 50 meters. Yeah, it's roughly 50 meters. So if I click on Mahavelikanga, zoom a bit further. Okay, so for Mahavelikanga, it should be 150. So if I check one side, roughly 150. The other side is also for Mahavelikanga is 150. Now we do have the buffered layers. So these are the actual protected areas under the Riparian Road and Riparian Act. Now we need to calculate the region, total region in hectares. So how many area is covered under this Road and Riparian Act. But the problem is which tool we are going to use is also another problem, and the other one there's two things. So we can simply do a geographic calculation, but the problem is if we do a geographic calculation right now we will end up with a problem. Because why? Here we do have, if I zoom in, let me zoom into a part. So if we do a simple calculation, it will calculate this same region which is covered by the road and the river twice. So it will count it as like 2 times. So we need to remove this river networks parts, and like we need to union or dissolve the fields into a one single layer to do the calculation. So how we can accommodate this part? So let's discuss now how we can do this one. We did the buffering and then we need to do the geometric analysis part. For the geographic analysis part, actually for this one, before the calculation of the hectare, we need to do the what we call area calculation. We can use the union tool for this one. Actually we need to use the union tool. So I will search for union tool from here. So under the analysis, click union tool. Then I need to input both road buffered layer and then the stream network buffered layer. After that, it's asking join all the attributes. So from here I have to select all the attributes to yes, yeah, all the attributes, and then I can click on Okay. Actually, I forget to give that part a name. It's better if you guys put a name for that specific part. So let me go to the union, the analysis part again. I will remove this stream network buffered file. I will click on the analysis tool again and then select these two layers, road network buffered and then stream network buffered, and then I can select this one is the union of road underscore stream. Then I can click. So here actually I need to select no FID. So if I select no FID, it will be much better. So let me copy this union road and stream network, and then I will remove this union part again from here because I need to do the calculation again. I will go to the search under the union. I will select input these two layers. One is road network and the buffered river network, and then I will place the union, and from here instead of all actually I need to select no FID. So from here I will take a screenshot of the union part. We have to do the union to remove the duplicates values. And then click on OK. Now is union. Now we need to do the dissolve part. After union you can see all the three layers were attached together. So now we need to do the dissolve part. So we need to go with the dissolve tool. I will search for the dissolve tool under the data management. Now I can select the input tool which has the union stream network. So this one will be union road and stream dissolve. So here I have to select the feature under which feature I am going to dissolve. I'm going to fill them blank and click OK. So it will dissolve all the fields into one single field. Now you can see previously I do have these road lines and these road buffer zones and the river buffer zones repeat two times, but now you can see those areas have been dissolved into one single file. So now we need to do the calculation of the actual area calculation. So I will right click on this one and zoom into the layer. So I don't need these two layers anymore. I will remove these all the other layers. Remove this one as well. So now I need to, this is the actual protected area under the Road and Riparian Act if we go alone. So now we need to do the calculation of the area. For the area calculation, what we can do, we can right click on this dissolved layer and open the attribute table, and then from here we can have a new field using add field, and then here I can type area underscore HA, and this one should be double because we are going to calculate area field, and I can click OK. Then I can click on this area hectare, right click on this area hectare file and do the calculate geometry, then click yes. So I will going to calculate the area, not the perimeter. So it's Kandala coordinate system. So I need to have this value in hectares. You can select any value. For me, I need to have this value in hectare. I will click yes. Now you can see in Kandy we do have 300 and how many 137,206.97 hectares were protected under this road and repair area act. So this is how you can do a simple calculation using this map, uh, using the arc map. So what tools we have used? We used how many tools we used? We use several tools in here. We use dissolve. I didn't put the dissolve tool in here. Let me put the dissolve tool as well. So now you can see my geodatabase file is here and my exe file is here. mxd file is there. So those are the two files. Geodatabase file is where you all the outputs are going to be stored, and then the mxd file is the file you need to have to open this map in the ArcMap window. So now if I need to send this one for someone, how should I send this one? I just need to copy this both ex0 file and ex0 mxd file and send it to the my friend or someone who needs this one. So now how we can like represent this one in a meaningful way? So it's totally up to you. You can decide. So in here I'm not going to design on like how we can do this one. Here we did a simple calculation on how many area. Okay, now if you need to know, okay, let's see, do a simple calculation for the Kandy district as well. So if I go into the Kandy district shape file, I can create another field in here. I will create another field in here as like the area underscore HA. This one should be double. Click OK. And if I right click here and do the calculation again, calculate geometry, yes, area should be in hectares, okay, yes. So the total area of Kandy district is uh, with this value. So this is the total area in hectares. And then under the Road and Riparian Act, it has covered this much hectare under the Riparian Act. So that's how we can do a simple calculation, and that's all for the first exercise as well. So we will discuss about the next exercise in the next session. So when you are uploading the files, make sure for the practical session, when you are uploading your practical session for the evaluation, you need to submit both of these files. Select on ex01 and ex01 GDB and like right click, and then you can add to archive and send this zip file for the evaluation. So then we can like evaluate how you have done your exercise. So when you are doing the zip file, actually you need to save this project, and then you have to close your arc map window, and then you have to do the zipping part. Uh, okay, after that you have to upload this file to the uh, link that we are going to provide you for the evaluation. So that's it for the first exercise. We will meet you with the second exercise. The second exercise we will do on multi-criteria evaluation, how we can do a size suitability analysis.